Mr. Sandman, bring me a dream. Make him the cutest that I've ever seen.
Hi. We all remember what it was like to be a kid and blow bubbles and how much fun that was. And we all know that the most enjoyment came by blowing the biggest and best bubbles. So our goal today is to find a way in order to blow the biggest bubbles to bring the most enjoyment to the most amount of kids. So now we'll be running you through the DMAIC model and how that aligns with the process of our experiment. So first we'll go through the D stage, define. Our customers in this example would be the children that are blowing the bubbles. So in order to identify our C2Qs, our critical to quality, we're going to define that as the diameter of the bubble that's being blown. Now our objective here, as we mentioned earlier, is to improve the children's bubble experience, and that'll come somewhat in the form of the size and the shape of the bubble. Now that we've defined our objective, it's time to move on to the measurement phase. Now we're going to start with our customer needs mapping. So we brainstormed 5 customer needs, specifically the lasting time of the bubble, the color, the diameter of the bubble, the floatness, and the durability. After that, we moved on and we distinguished our quality characteristics, and we identified the most important quality characteristic as the viscosity of the solution that we'll be using to make the bubbles. Now we're moving on to the second phase of the measurement stage. Our goal here is to validate our measurement methods. So what we've done is we've taken 10 samples done by 5 different operators with 3 iterations in order to get a gauge R&R. So to measure, we'll be blowing a bubble on a table until it pops, and then using our ruler to measure the diameter of the bubble that is popped on the table at its max volume. So as you've seen, we blew the bubble to the max capacity, and as it's popped, we'll now be measuring the diameter to see the overall circumference of the bubble. As we can see, it's just about 7.8 millimeters wide. When looking at our outputs from Minitab, we can see that our components of variation is at 6.98%. This is good as it's less than 10% the usual threshold. Now, our R chart by operators, all but 1 point are within the control limits. Our X-bar chart by operators, the majority of the points are outside the control limits. When we're looking at diameter by bubble, we see a relatively similar pattern. The diameter by operators, we see a very similar pattern. And the bubble operators interaction, we see diverging points throughout. So this indicates that our overall Minitab analysis shows that our measurement process is valid and accurate. As we've now validated our measurement system, it's time to move on to the analysis phase. Now we look at this cause and effect chart. And as we know this is a manufacturing process, we use the 5 M's. That's measurement, method, manpower, material, and machine. So we looked at all 5 of these M's, and we figured the easiest for a child to manipulate in their own home while trying to produce the best bubbles would be the materials. So different type of ingredients and soaps and type of waters. So we figured that this would be the best scope for our analysis in the future. Further analysis of our 150 base samples shows a mean at around 6 millimeters. Now this is pretty small when considering what the kids are expecting for in their bubbles. Now it's time for the fun part. As we mentioned earlier, one of the key characteristics is the viscosity of the solution when it comes to the quality of the bubble. So we thought to ourselves, now that it's time to improve the experiment and move on to the DOE, the design of the experiment, we figured what are some materials that kids could find around their house in order to improve the solution on their own. So we figured we could start with tea, which would be an easy one to find in any kitchen. We figured glue, which is something that could obviously change the viscosity and something that you could find in any arts and crafts set. And we figured sugar and salt, which you could also find in any kitchen. Now we decided to use each of these elements independently as well and mix with each other in order to find the perfect solution to make the perfect bubble. Continuing with the improvement stage, we will now look at the Pareto chart, and as we can see, term C is T and it has the biggest effect, followed by A and D, which is salt and glue, followed by glue alone. Now we'll look at the main effects for plot diameter. As we can see, T has a very large impact here, as well as glue. When we look at salt and sugar, they have an overall negative effect, but it's closer to neutral. Now moving on to the interaction, we see when salt and glue and sugar or glue are put together, we get a positive reaction, but the best reaction we see here is salt and tea when combined together. Now moving on to looking at our coefficients in a linear regression, by analyzing our coded coefficient, we see that the best effect is actually when we put all 4 elements together, we get the biggest diameter of bubble. Now that we've seen the combined results and the overall regression, we've discovered by that combining all 4 elements, we get the best viscosity and the best overall solution to creating the biggest diameter of the bubbles. So now we're moving on to the control phase, our final phase, and we want to make sure this experiment and this process as a whole is as repeatable as possible for the kids at home. So we're going to give you our little bit of the solution we've been using so it's as controllable as possible. For every liter of water, we've been using 2 tablespoons of dish soap. We've been using 2 tea bags per liter of water, as well as 1 tablespoon of glue, and 1 tablespoon of salt, and 1 tablespoon of sugar. Now, if you follow these ratios in proportion, you should receive relatively similar results that we've received thus far. Hopefully you've enjoyed following us through the DMAIC model today, and you've learned a lot. Now remember that this model can be used for almost any process or product that you're trying to improve on in your own life or in your own work. Thank you for your time.
Mr. Sandman, bring me